right, don't you hate it when you cut into an apple and then it's just brown and nasty and gross? Well, today we're going to take a look at the science behind that and what you can do maybe to stop it. So today is a fun science experiment that you can do at home right now. Let's get to the video. Okay, so basically what's going on here is a process called oxidation, and it happens to almost everything that's plant and animal material, and it's kind of good with the breakdown process of returning things back to nature. But when an apple turns brown, it's happening because of an enzyme. Okay, now the enzyme is called PPO, where the O stands for oxidase. And anytime you hear ACE, that basically means it's oxidizing. Now, we talked a little bit about oxidation in the video that I did with steel wool burning, and if you want to go ahead and check that video out, I'll link it right there. Pretty cool thing you can do if you're into photography. But oxidation is a partner in a reaction called a redox reaction, or reduction and oxidation, where usually both are happening as electrons shift places. For more on the exact chemistry of that, I'll put a link to a video right there. It's sort of a chemistry tutorial on redox reactions, but you're going to see a couple of them here today. So we're going to cut open an apple and we're going to leave it out for the air, but we're also going to do a time lapse with one that is coated in lemon juice. Now, lemon juice is a common acid called citric acid, and we're going to see if that actually improves or doesn't improve the whole oxidative process. There's a couple other things we're going to try. We're going to try some hydrogen peroxide. Now, hydrogen peroxide is similar to water, which is H2O, but it's H2O2, so it has an extra oxygen. So maybe this will make the oxidative process better or worse, faster or slower. This could have an effect as well, so we're going to talk about that. And then the last thing we're going to do is we're going to dip it in some water, which is just H2O, and we're going to see how that compares. So we'll set up our time lapse of those 4 trials, and then we'll just see which one happens to work the best or worst, depending on what you're looking for. Now's the time to predict. What do you think? Do you think that air is going to oxidize or turn the apple brown faster or slower? What about water, peroxide, or lemon juice? How do you think those things will contribute to the oxidative process? So go ahead and write an observation down. If you want to put that in the comments, that'd be pretty cool. I'd love to see how many people predict certain things before they see the next part of the video. So go ahead and do that right now. Okay, cool. So I have those 4 trials set up under a time lapse. They've all been dipped in whatever they're going to be in for about 30 seconds, except the control, which is the one exposed to the air. As you are going through your observations with the time lapse going, go ahead and jot some stuff down. If you want to pop open a Google Doc or just get a pen and paper, write down everything that you notice. You've got your prediction, so now it's just time to observe it. Let's go.
I seriously underestimated how boring a time lapse of an apple turning brown could actually be. So here I have just a couple still pictures. I'll rotate the plate, but P stands for peroxide, W for water, A for air, and L for lemon juice. So go ahead and take a look at this and write down your observations.
You saw the oxidative process happening with air, with hydrogen peroxide, with lemon juice, and with water. So what I'd like you to do now is just think a little bit about that and what you might know or not know, what you might think, what you might guess, is what is it that's actually causing that phenomena to happen? So it's time to explain it.
Okay guys, so hopefully you had a chance to explain it before I go ahead and kill it. If you haven't, just enjoy some of this elevator footage with elevator music.
All right, I mentioned PPO earlier. PPO stands for polyphenol oxidase. And so that enzyme is responsible for what's going on with the apple. Now, there's a couple different ways to inactivate that enzyme that exists already in the apple. So one of them is that all enzymes are pH dependent. So in other words, the acidity level can make it lower or higher, and that could actually affect the impact of this PPO because it's an enzyme. So if we shift the pH range too low, too acidic, or too high, then it won't work. Now, if you're curious about acids and bases and neutralization, all that stuff, I did a video a long time ago. I'll go ahead and link that right there. You can go check that out to help you understand that a little bit better if you don't. So that's one way. Temperature would be another way. And then we can also just sort of seal it off. So sometimes you might notice that apples in a plastic bag don't brown as quickly as those that are exposed to the air.
Where did all the apple slices go?
Lemon juice? Maybe. If you like that taste of lemon with apple, especially if you're using sour apples, which brings up an interesting point. It's time for you to extend it. Okay, so in the extended part of this, how can you take this a step further? Now, I mentioned sour apples. Green. Do green apples brown as fast as red ones? That's something you can check out. What about yellow apples? What about the super deep red or ones that come from different parts of the world? So maybe there's something you can try there. What other things do you have around the house that you could test to see if it helps your apples stay fresher longer? What I'd love for you to do is to go ahead and make me a video, keep it about a minute of what you tried, what the results were, and what we're going to do is we're going to call this the Apple Slice Challenge. And go ahead and tag me at BaldSci on Facebook, Instagram, or Twitter. I'd love to see what you come up with. All right, until next time, this is Brian with Bald Guy Sci, and we will catch you later.